Hello guys, good evening. Welcome to the session today. Hope you all are doing good. So let us start the session. So if you remember, I have given you some idea about what is Google Cloud Data Engineering yesterday. What is actually the data engineering? If you wanted to become a data engineer, so what are the aspects that you have to focus on? And when it comes to the Google Cloud Platform, so today onwards, we are going to enter into the Google Cloud Platform. We will be understanding the basic concepts related to the Google Cloud Platform. And after that, we will start the data engineering concepts, how we can able to implement the end-to-end data pipelines in the Google Cloud Platform. Let us see. Okay. So for the Google Cloud Platform, so we are going to start with the cloud overview. This is what I have told you yesterday also. Let me just start from the cloud overview. So these are all the topics that we are going to discuss one by one. Okay, so all of these are the basic concepts related to the Google Cloud Platform. If one wanted to become a cloud developer, he needs to know all of these things. He's supposed to know, even though it is not related to the Google Cloud Platform. For example, if I'm learning the console, shell, SDK, or the locations concept, IAM and admin concepts, these are not specific to the Google Cloud Platform. If you know this knowledge can be useful in the Azure as well as AWS also. Okay, so you can have the whenever you are learning some cloud platform, you need not to learn the one more cloud platform specifically, because if you are familiar with the already one cloud platform, you are already having some knowledge on the other cloud platforms as well. Okay, so let us start with the so these are the tools that we are going to learn in our session. And let us start with why we need a cloud platform and why companies have started using the cloud platforms. What is the main intention and what is the actual requirement? How a project will start, and when the project starts, what are the things that the that the developers will work on? How the other team members will work on? How the entire project looks like? How the infrastructure will be taken care? All of those things. Let us try to understand with a simple illustration. So let me start with that. Assume that, try to assume this one, guys. Okay, assume that, let's consider if an organization wanted to roll out a new application. Okay, think that usually most of the organization will have their own requirement. So based on the requirement, they wanted to roll out a new application. So if they wanted to roll out a new application, a business will come into the picture. Business come up with the requirements for the application. Okay, so if you wanted to create one entire new application, so business comes up with a what kind of a application that we are going to build and what are the requirements for that particular application. So that's where the application begins. Okay, the adventure for the new application begins. And next, business analyst come into the picture. He will gather all the requirements as well as needs from the business and analyzes it and converts that into a set of high level technical requirements. Okay, what the business analyst will do, he will get all the requirements from the business and he will try to analyze it. And once he analyzed, all of those analysis will be converting it into the high technical requirements. And once he have set that requirements properly, then he will be passing that information to the solution architect. What the solution architect will do, a solution architect will do, now what he will think is like, whatever the requirements that was passed from the business analyst, he will gather that information and he will now build the solution or the architecture design that the architecture to be followed for the deployment of this new application. So whatever the application they wanted to build out, right? So for that one, he will be creating the architecture to be followed for the deployment of this application. So this is what we call as an architecture diagram. In this architecture diagram, what is our source? What is our destination? What is the infrastructure requirement? How we are going to deploy the application, what is the strategy for the deployment, all of those things will be properly displayed. So that's what the solution architect will do. Solution architect is the one who will be building the entire solution for the particular new application that we are going to. That means so far it was just a design that we were talking about. Now he will actually implement the steps to be followed to achieve that new application in terms of the deployment, in terms of the infrastructure, in terms of the tools that we are going to use it. All the information will be properly displayed as an architecture. So that architecture is going to be followed for the deployment of this application. Okay, and while doing it, he will also include the infrastructure such as specification type, the number of servers needed for this front end web server, or the back end web servers, or the databases, or the load balancers. All of those things he will list it out. Okay, see, if you can think that, sir, I am working on the data engineering. So for the data engineering, I need one solution. So you wanted to recreate some table and you wanted to do some kind of analysis. But if you wanted to do all of those things, you need to have a specific infrastructure to be built, so that you, on top of that infrastructure only, you are going to create those reports. Without the infrastructure, you can't do anything. So that's where the solution architect not only thinks in terms of the project, he will also think in terms of the infrastructure. Okay, so that architecture will involve many things that typically include the infrastructure, such as number of servers, or the front end web server if you need, and the back end servers such as databases or the load balancers. He will include everything. Okay, so now what will happen is that in the traditional model, if you look at it, so whenever the solution architect has mentioned this entire diagram, whatever the things that are there, right? So for example, the load balancers or the web servers or the backend databases, if all of those things are available in the house or available in the organization, then there is no problem. Okay, so when you follow the traditional model, this would have been deployed in an organization in on-premises environment, which would mean making this use of these assets in the data center. Each organization have its own data center, and we are going to deploy it on top of that data center only. If the additional hardware is needed, they would have to order it via procurement team. Okay, so if the additional hardware is needed, what does that mean, sir? So as the architect, solution architect mentioned, these tools we are going to use it, this infrastructure we are going to use it. In when he mentions it, if that particular additional particular hardware is not available in the data center, they have to order it via procurement team, and this team will put in a new request to the vendors. Now it will take days or weeks or even months for the hardware to be purchased and delivered to the data centers. Okay, so whenever the solution architect, whatever the things that he has mentioned in the architecture, all of those things has to be available in the data center in terms of the infrastructure I'm talking about. Okay, if the all the infrastructure or the hardware what we are going to deploy, all of those things has to be available in the data center. If it is not available, a procurement team come into the picture and they have to order it, or they have to place a new request to the vendors. Okay, this can take a lot of time. It can take a days or a weeks, even months for the hardware to be purchased and delivered to the data center. And once it is received at the data centers, the field engineers come into the picture, and they are the in charge of the rack and stack of the equipment. Then the system admins or network admins come into the picture. The system admins will do the system configuration. Network admin make the system available on the network, and the storage admins will come into the picture, and they will assign the storage to the servers. Backup admin will configure the backups, and finally, once the system is available as per the standard, then that will be handed over to the application team. And as per the diagram or as per the architecture, application team will be deploying their application on top of these infrastructure, which was built by the field engineers, system network admins, storage admins, backup admins, all of these things. Okay, so this is what happens in the real world. Now look at here, what is the problem? So if I have to say in a one sentence, business business managers will get the requirement for the new application. They will be passing that information to the business analyst. Business analyst will analyze the entire thing, and he will be passing that information to the solution architect. Solution architect will, based on the requirement, he will create an entire architecture diagram to be followed for the new deployment of the application. And for that, whatever the infrastructure that is needed, if it is already available in the data center, they need not to place any new request. If it is not available in the data center, they have to, the procurement team will place a new request to the vendors. The vendors has to move the infrastructure or the hardware required to the data center. And once that hardware is available in the data center, field engineers will take care of the rack and stack. System admins will take care of the initial configurations. Network admins take care of the systems to be available over the network. Storage admins will take care of the storage configurations and server configurations. Backup admin will take care of the backup of this all of these things. And then the application team create their own code for the application to be developed, and that will be deployed over this infrastructure. Okay, this is how the traditional model looks like. Now, what is the problem with the traditional models? There are plenty of the disadvantages that people were facing in the traditional, because earlier, if you go back to the 10 years before, most of the organizations were following this architecture only, or this kind of a model only. This is what we call as a traditional model or on-premises working model. The very first thing that the people were facing is slow deployment, because the turnover time varies from the weeks to months to everything ready for the application deployment. Okay, so because if that hardware is not available, all the things has to be purchased, move it to the data center, field engineer system, everything takes a lot of time. So that is the reason the deployment process is very slow. If you wanted to roll out a new application, it again, we have to go through all of these steps again. So that is the reason we call it as a slow deployment model. The traditional model is a slow deployment model comparatively, and it is very expensive. Okay, the overall cost to deploy and maintain this model is very high, because many people are involved, and we have to recruit a new people and skilled people. We have to recruit for the field engineers, system, storage admins, backup admins. All of these things are came into the picture. The overall cost to deploy and maintain this traditional model is very, very high comparatively. And the automation is very limited, because you see here, some of the things cannot be automated. Take things like field engineers, system configurations, network configuration. So such kind of a things cannot be automated. While some aspects of the infrastructure can be automated, but several steps such as rack and stack cabling or other deployment procedures are manual and very slow. So that's the reason in a traditional working model, the automation is limited. And one more thing is that human error. With so many teams working on this many different tasks, the chances of human error is very high. This result in inconsistent in environment. Okay, so the human error is very high because many teams are working. So when I say field engineers, that is entirely new team. System team, storage team, backup team, there are plenty of the people are involved to make everything ready. So that is the reason the human error is very high, because they are working on a different tasks. There is a bound, there are chances of getting human errors. And another major disadvantage is that you buy the hardware, you do not know how much you are going to use it. So the underutilization of compute resources, that is the biggest disadvantage with the traditional model. That means you are going to waste the resources. You wanted to buy only 100 GB of the disk, but you can't just buy 100 GB. Okay, you can't just buy a 100 GB disk. So if you wanted to procure something via procurement team, when you place a request, they're going to be buying the 1000 GB disk. Okay, so when you are buying it, when you are using it, utilizing it, You are only utilizing the 100 GB, 900 GB is getting wasted. So this is comes under underutilization of the compute resources. This is one of the biggest disadvantage, I would say. Okay, due to the traditional model, the deployment is very slow. That means the turnover time is very high. Okay, and if you wanted to scale up the things, or if you wanted to scale down the infrastructure, it actually takes a lot of time, because when you wanted to scaling up or scaling down the infrastructure on demand cannot be achieved very quickly. Okay, so many teams are working behind the scene. The overall cost of the deployment is very high, and the automation is limited. Many teams are working, human error is very high. It leads to the inconsistency environment. And finally, the waste of resources. Okay, underutilization of compute resources is also one more disadvantage. So these are all the disadvantages of the traditional working model. Due to these many disadvantages over the past decades, organizations moving to the cloud platforms to take the advantages of the services provided by the major cloud providers such as AWS, Azure, and Google Cloud Platform. Okay, what is the advantage that you get, sir? See, you don't need to work with these many people. You don't need to work with these many people, and all the things are working via APIs, application programming interfaces. And when you need the resources, you don't need to wait for anyone. You can just directly utilize it, and whatever the resources that you are utilizing, you can just pay the money for them. So that's how the cloud computing works. So that is the reason the deployment model is very high. Okay, that means we have a faster deployments. And one more thing is, it's not cost effective. It's a cost effective model, because today if I need something, I'll only be utilizing it, and whatever the thing that you are utilizing, you only pay for that. You don't pay extra, you don't pay less, you don't only pay for the enough resources that you are utilizing it. And limited automation is also because the automation could be very high. When you're working in the cloud provider, all the things are working via APIs. So when something is working via APIs, the automation becomes very high. So automation is very high compared to the traditional models. And you don't need field engineers, you don't need to worry about the network system admins, storage admins, backup admins, because cloud provider already taking care of these things. You don't need to worry about it. All the things they will be providing you. So humans are very less. That's the reason human error will not be there, and inconsistency in the environment will also be less. And we are not wasting the resources, because we will only be utilizing the resources that are required for our application. And if you wanted to scale up tomorrow, you can scale it up. If you wanted to scale down tomorrow, you can also scale it down according to your requirement of your application, or according to the traffic of your application. So all the things are there. So wasted resources is also not there. So you are already using the resources, compute resources, how much you need, and you only pay for that. So this is the reason, compared to the traditional model, cloud providers or cloud computing services become very high. That is the reason most of the organizations started using these cloud computing services, and one of such cloud platform is a Google Cloud Platform. One of such platform is a Google Cloud Platform, guys. Okay, so AWS provides you the cloud computing services, Azure provides you the cloud computing services, Google Cloud Platform provides you the cloud computing services. Out of that, Google Cloud provides you the services cost effectively. So that is the reason most of the companies are nowadays looking towards a Google Cloud Platform. There are plenty of the opportunities. In our course, we are going to focus on the GCP. Okay, hope this is clear. Okay, so let us enter into the Google Cloud Platform. Hope you guys got some idea how the on-prem works, how the traditional model looks like. And now let us try to understand what is the Google Cloud Platform. Okay, so let me try to differentiate the differences between the Google Cloud Platform as a on-premises working model. So when you are working in the on-premises, if I have to say in one word, an organization managing its own infrastructure to run their application or a code. In a simple word, if I have to say, what is traditional working model, sir, or on-premises working model? In an on-premises working model, the, the organization has to manage its own infrastructure. When I say infrastructure, you can think of like a server or a hardware, software, networking, and storage. So organization has to managing its own infrastructure, so that's what we call as a traditional working model. Okay, if the organization is unable to manage their infrastructure, they can depend on the cloud computing services. So that kind of era that we are in, that is what we call as a cloud computing working model. Okay, in a cloud computing working model, cloud provider delivers the infrastructure as a service. Okay, they provide you the cloud computing services as a cloud computing services. Either they provide you infrastructure as a service, or a software as a service, or a platform as a service. Okay, so you don't need to create your own infrastructure, or you don't need to create your own servers, or you don't need to create your own databases. Everything is already readily available. You just have to configure them. Okay, so that's the difference between the on-premises working model or a cloud computing working model. In simple words, if I have to stay in Hyderabad, for example, think like this. If I got a job in Hyderabad, there are two ways that I can do. One is I can construct my own home, or I can rent a house. Okay, one is to construct a home. For constructing a home, there are many things that I have to take care. For renting a house, I can just rent it out for some time, and tomorrow if I wanted to leave it, I can do that. So cloud computing is exactly renting the infrastructure. Okay, you are just renting the infrastructure for some time from some cloud provider, and whatever the things that you are renting, you will be just paying the money. So that's what is a cloud computing working model. In on-premises, you construct your entire house. Okay, so this is the difference between the on-premises working model and cloud computing working model. And in cloud computing, we have actually three types of models. So in another words, if you try to understand this point, actually this gives you a very good knowledge, guys. Just focus on this point. When you're working on the on-premises model, you have a very single model, that is you have to take care of your physical infrastructure. That means if you need a server, you have to buy it. If you need a disk, you have to go and buy and ship it to your data center, and again you have to use it. If you wanted to manage your virtual machines, you have to manage your own virtual machines. If you wanted to manage the platform, you have to manage your platform. And then you have to focus on the development of the solution. Assume like this. Assume like this. So for example, in an organization, if you think that this is your organization, assume that this is your organization. The organization will have plenty of the projects. Assume that one of the project. Okay, one of the project. So each project will have its own requirement. Okay, each project will have its own requirement. So for this requirement, we need two things. One is manpower, that I call as the developers. One more is infrastructure. Infra power. One is manpower, one more is infra power. Manpower is nothing but a we. We are all manpower, nothing but a we developers, managers, program developers, or many things. And infrastructure, nothing but a, when I say servers, hardware, networking, storage, all of those things. Okay, so when you're working in on-premises working model, you have to take care of your own thing, and then you focus on the requirement. Then you focus on this requirement. To fulfill the requirement, you are going to develop the solution. Okay, so in this project, you have a requirement. To fulfill the requirement, what you do, once this developers and infrastructure is ready, you will create a code, or you will create a solution. Okay, once everything is ready. In an on-premises working model, you have to take care of all of these things for the infrastructure. Okay, so you have to buy your infrastructure, you have to ship it to your own data center, You have to take care of the system configuration, network configuration, backup, storage, all of those things you have to do it. And if you need to have a virtual machines, you have to create your own virtual machines. And then you have to install, for example, you are developing a Java application. So you have to install the Java dependencies and then install the Java application. On top of the Java application, you are going to write your code for your requirement. On top of your Java application, you are going to write your own code. So this is what happens. That means, so until the developers, this is where the developers are working on. Until the developers creating the code, all of these things has to be ready. Without these things, whatever the development, what they are doing, they cannot test it. They cannot deploy anything. So developers are wasting a lot of time here. So that's what in an on-premises working model is, that the model is very slow. And when you go to the cloud, you have three working models. One is VM based services, nothing but a virtual machine based services. One more is managed services. The third one is serverless services. Okay, what are the three things, guys? VM based services, managed services, serverless services. When you're working on a VM based services in the cloud platform, you don't need to buy any infrastructure. You don't need to buy any physical infrastructure. Cloud provider will take care of it, because you are working in a cloud provider. You are working with a cloud computing working model. Cloud provider you have selected. So you don't need to buy the physical infrastructure. That will be taken care by your cloud provider. Then you have to take care of your virtual machines, installation and a platform configuration. Then you can go for the development of your solution, development or deployment of your solution. Okay, so here you have to take care of all four things. Your organization has to take care of all of these things. If you opted for this model, you have to take care of only three things. And when it comes to the second working model, that is managed in cloud platform, you don't need to worry about the physical infrastructure. You don't need to worry about the virtual machine configurations. You just have to install your own application or configure your own application and develop your solution on top of that application. Okay, so here you are taking care of only two things.
Sir, here the managed virtual machines means the middle tier, right?
Yes, yes. If you have any questions, I will give you a time. Okay, so many people are here, so let's not take it this time for the questions, but you can keep it in the chat. While I am talking, I will be seeing the screen and I will talk about that also. I will try to answer that now itself. Okay, put it on the chat. And now, when it comes to the serverless, you don't need to worry about the physical infrastructure. You don't need to worry about the virtual machines. You don't need to worry about creating your own application platform. You just have to focus on the development of the solution, how beautiful it is. You're just focusing on the development. You are not taking care of any infrastructure related activities. Okay. So when you are working in the on-premises, there are many things that you are going to take care. But when you're working in the cloud platform, you are only taking care of the how much amount of the infrastructure you wanted to take care. If you wanted to take care all only the virtual machines and application, then you go for the VM based services in the cloud. If you wanted to take care of only the application configuration, then you go for the managed services. And you don't wanted to manage any infrastructure. I just wanted to develop my solution. If you wanted to have such kind of things, go for the serverless services in the cloud platform. Okay, the one of the best example for the serverless is BigQuery. One of the example for the managed services is Dataproc. One of the example for the VM based services is virtual machines, nothing but a compute engines. Okay, so this is how it works, guys. Okay, so compute engines are the VM best example for the virtual machine based. That means an entire machine will be given it to you. Okay, when an entire machine is given it to you, you can do anything. If you wanted to create a virtual machines, if you wanted to create something, this one, that one, you can do whatever you want. And managed services, you can create your own cluster. You can create your own machines. You can create your own application on top of it. Best example for the Dataproc is a managed service. Serverless, you don't need to worry about any infrastructure here. You don't need to worry about any infrastructure here. You just focus on the development. That's what we do, right? That's what we need as a data engineer. I am the person who will be focusing on the data processing and data analysis. I don't want it to take care of the infrastructure. Okay, such kind of a services that the cloud platforms providing you. And these are the examples from the Google Cloud, guys. Don't worry about other clouds. Okay, as I mentioned here, green color, you as a developer don't need to do it. Google manages it for you. And the orange color, you as a developer need to do it. Okay, so this is what is the difference. Best example for the on-premises versus cloud. Okay, yeah, I'm gonna give 5 minutes or 2 minutes. If anyone have any questions, you can put it in the chat. I'm gonna take it up. If you guys have any questions related to this one or until this concept, if you have any questions, because I'm going to take a one example so that you are going to understand this point very clearly. Okay, so if you have any questions, put it in the chat. I'm going to take it for you guys. I see no questions. Okay, I think there are no questions. People are very clear about the concepts. That's well and good. Now let's look into a small practical example to understand these differences between the on-premises, virtual machine-based services, and managed services, and serverless services. See, as a GCP data engineer, you are connected with a client. Assume that there's a client and he is expecting something from you. He is expecting something from you. As a data engineer, you are requested to store and process CSV data. Okay, the amount of data is 1 TB. Okay, you have CSV 1 terabyte of the data, and this is what is the input file, and your end user wanted to access it in a table format using the SQL. Okay, so he wanted to have this data. It is in a CSV file. You can think of like a CSV file will be like this: your data, comma, your data, comma, your data, comma, data, comma, data. So that is how CSV file, comma separated file looks like. And he don't wanted to look it like this. He wanted to have this data in the form of a table. He wanted this data to be in the form of a table, and he wanted to write SQL queries to do some kind of analysis. Okay, this is what he is expecting from me. This is the input. This is the expectation. What he is expecting, sir? He wanted to have the data in one of the table, and whenever he write or whenever he fire one query, and he wanted to see the result from that particular table. So that is what is the expectation from you. Now think about it. And now think about it and tell me, how do you solve the request? Okay, put it in the chat. I'm going to read it out. Okay, think about it. Take 1 minute, guys. And how do you solve it? Put it in the chat. Okay, yeah. I'm going to give you 1 minute. So you guys do not know that, right? Okay, that's fine. So I'm going to explain it to you. See, if I wanted to do this thing, if I wanted to store this much amount of data, okay, this is what is my request. And if I wanted to store this much amount of data, if it is a on-premise, what I will do, I will tell you. I will put in a request to my hardware team or a procurement team to request for the some amount of infrastructure such as machines, networking, storage, backup. All of these things I will request. Once the storage is available, I am going to store this CSV data here. Once this is done, on top of the one of the machine, on top of this machine, okay, this is, you can think of like this is a machine, okay, some one machine, one Windows machine or whatever. On top of this machine, I am going to create some cluster, a cluster of virtual machines, a cluster of 3 machines. On top of that, I am going to install Hadoop to store this data, and to process the data, I'm going to install Hive so that I'll be able to have this data in the form of a table. So this is what I will do in on-premises. In on-premises, what I will do, sir? In on-premises, I am going to buy a new machine, or I am going to put in a request to my procurement team to have one entire machine for me, and where I am going to store, I am going to first create a cluster and cluster of 3 or 4 machines. On top of the cluster, I'm going to install all the softwares that I require. Once the softwares are created, I am going to store the data on top of the Hadoop. And once the data is available in the Hadoop, I am going to create a table in the Hive using this Hadoop table, Hadoop data. And once the data is there in the Hive table, then you can run SQL queries on top of this table. This is what I do in the on-premises. From the scratch, from the buying the machine until the SQL query, I am going to take care of everything. So this is what you are going to work on in the on-premises. But people are hesitate, or people are don't wanted to work on it because there is a lot of effort needed, lot of time is getting wasted, lot of money is getting wasted. So people don't wanted to work it on it. So that is where we have 3 solutions from the cloud provider. I'm going to explain you those things. One of the solution is VM based services. Next one is managed services. The third one is serverless services. So when you go and work in the VM based services, you don't need to buy any machine. Okay, you can just provision a multiple virtual instances in the GCP using the compute engine. You can go to the compute engines in the GCP and you can create a virtual machines. And on top of the virtual machine, you can install Hadoop cluster. You can install Hadoop cluster on top of it. And then you can store the HDFS. You can store the data in the HDFS, nothing but a Hadoop distributed file system, and create a Hive table on top of the Hadoop cluster. Okay, so this is what I'm going to do. So buying or purchasing the machine was getting not required here, because already the cloud provider providing you the compute engines, so you can create your own machine here and you pay for the whatever the resources that you are using it. So in a VM based services, an entire virtual machine is readily available. You just configure it and install the Hadoop cluster on top of it and store the data in the HDFS and create a Hive table on top of the Hadoop cluster. So this is what you are going to do in the VM based services. And when you go to the managed services, you have a data proc which already comes up with the Hadoop, and Spark. You don't need to install the Hadoop separately. You can just create a data proc cluster, and it is already coming up with the Hadoop and all of those things, and Hive, Hadoop, HDFS, everything. You store the data in the HDFS and create a Hive table. Okay, you store the data in the HDFS, you create a Hive table. And when you are working in the, if you wanted to work in the serverless, you can directly store the data in the BigQuery table, and it is a fully managed service for a data warehouse. And once the data is there in the BigQuery table, you can write SQL queries directly. Only one step. Just move the data from CSV to the BigQuery directly. BigQuery already supports the CSV files, JSON files, Avro files, Parquet files, ORC files, all of those formats that the BigQuery supports. And you can store the data here in the BigQuery. And then once the data is there in the BigQuery provides you the very built-in query engine, and it supports writing queries, and it has an editor and very simple and easy to use interface. You can write your queries in the SQL, very simple language. So these are the 3 possible scenarios. So when you wanted to solve this particular example, you have three solutions in the Google Cloud Platform. This is one, this is two, and this is three. Okay, so these are the three possible scenarios. So this is how the Google Cloud looks like. I just wanted to give you, so when I give you the Google Cloud Platform, what is Google Cloud Platform? This is how the Google Cloud Platform looks like. If you wanted to try out a new application, or if you wanted to create a new application, build a new application, scale it out, all of those things. For every situation that you have or every problem that you're facing in your project, there is a possible solution in the Google Cloud Platform. Okay, so that for that purpose, and if you have a infrastructure overhead on top of you, and we have a three different varieties of services: VM based, managed, and serverless. If you have a infrastructure overhead, go for the serverless platform. If you do not have, sir, I can able to manage my infrastructure, then go to the VM based services. Okay, so this is how the Google Cloud Platform services looks like. And if I have to talk about how many services, category of services the GCP provides you, this is what we call as a GCP suite. And here we have compute services, identity services, networking services, big data services, storage and database services, machine learning services. 1, 2, 3, 4, 5, 6, and 7. All of these services that the Google Cloud Platform providing you, this is what we call as a GCP suite. And we already know what is Google Cloud Platform. Google Cloud Platform is a suite of cloud computing services provided by the Google that offers range of products and solutions to help organizations build, deploy, and scale applications in the cloud. Okay, so if you wanted to build an application, if you wanted to deploy one application, or if you wanted to scale one application, Google Cloud Platform provides you the cloud computing services for that particular activity. And these services are highly reliable, secure, and scalable infrastructure that enables businesses to leverage the power of Google's extensive global network and data centers. These global network and data centers are situated in different regions, as well as it is already available in the multi regions. Even in India also we have two data centers in Mumbai and Delhi. Okay, so that is how Google Cloud Platform is providing you the cloud computing services. If one organization wanted to build their application or deploy their application or scale their applications in the cloud, for all of those things you have a specific services available in the Google Cloud Platform. You can leverage the Google's extensive global network and data centers for that particular use case. Great. Yeah. And why we learn the GCP? In single chart, I'm going to tell you guys, Google has a very good community support. Plenty of the people are already started using the Google Cloud Platform, and Google has its own community support. And all the services that the Google Cloud providing is compared to the AWS and Azure, the services are cost effective. The services are cheap compared to the AWS and Azure. And these services are flexible, scaling up and down, you can able to do it easily, reliable, secure, fully managed, nothing but a serverless. The interface looks very simple and easy, and you can able to all the services working very fast, so you can able to use the Google Cloud Platform for your own organizations to build and deploy your applications in the cloud platform. And it's a market leader from the from the startup companies to the high MNC companies. Most of the companies are already started using the Google Cloud Platform, and GCP is one of the leading and cloud platforms globally with a wide range of services and strong presence in the various industries. And many organizations from the startups to the enterprises are adopting to the Google Cloud Platform for cloud infrastructure, making GCP is highly valuable in the job market. And one more thing, it has a comprehensive service portfolio. As I was telling you already, if you can look back, this is a comprehensive service portfolio. These many services that the Google Cloud Platform already providing you guys. Okay. comprehensive service portfolio, integration and compatibility. This is very important, right? GCP services can be integrated well with other global cloud services. If you wanted to use Google Analytics, you wanted to use Google Maps, you wanted to use G Drive, you wanted to use YouTube, you wanted to use many services. If you wanted to integrate it with any of the services in the Google products, can be easily integrated. Not only that, can be integrated with other cloud platforms as well, can be integrated with the on-premises services as well. Okay, so integration and compatibility will be to the internal Google products and to the outside on-premises services and to the other cloud platform providing services like AWS and Azure. Google is providing you the very good capabilities for the machine learning. GCP offers powerful machine learning services and tools. If I have to name it, TensorFlow, AutoML, VetXI. So if you wanted to use Google Cloud Platform for the AI services or ML services, you can actually go for it. And Google has a very good global infrastructure. There is a vast network data centers are available over the worldwide, and the latency of these services is very less. The performance is very high. And Google Cloud Platform, and one more advantage with the if you are learning the Google Cloud Platform, because so far earlier 10 years before we were on-premises working model or a traditional working model, and after that we are working in the cloud, and some companies are already habituated to work on in multi-cloud era. That is going to come in next, guys. Multi-cloud era. In this multi-cloud era, if you're working in one project, 2 or 3 services from the Azure, 2 or 3 services from the AWS, 2 or 3 services from the GCP. That's how the projects are going to be in the next trend. This is how, because, and from the community, I would say that one of the community member, I would say that Azure is very famous nowadays for the CI/CD. AWS is very famous for the machine learning, and for GCP is very famous for the big data projects, very famous for the big data projects. So Azure is very famous for the CI/CD implementations. Azure is very famous for the AI and ML services. GCP is very famous for the big data projects. So that is the reason there are chances. It's not chances. It's some big companies are already using the multi-cloud, and in the next trend is multi-cloud era, I would say. And learning the GCP and doing a certification will eventually gives you a very good career growth. Okay, GCP certifications are validate your knowledge and expertise and increasing your career opportunities and earning potential in the cloud industries. So that's what the Google Cloud Platform is for. Okay, so these are all the scenarios that I have mentioned here. Will tell you why we need to learn the GCP. Okay, and you can see here the growth rate. Growth rate. 54% of the growth rate is there for the Google Cloud Platform. 51 for the Azure, AWS 32%. Okay, so the growth rate is very high for the Google Cloud Platform in the last quarter. Okay, so this is how I would say that. And Google Cloud Platform, GCP roles offered: GCP data engineer, GCP developer, GCP admin, GCP DevOps engineer. I forgot to mention GCP DevOps engineer, GCP machine learning engineer, machine learning scientist. So many Google Cloud is offering you, and this course is mainly focusing on these three. You can go for GCP data engineer. This course will help you for the GCP developers as well. GCP admin concepts also we are going to cover. But this course is totally inclined towards GCP data engineer. And course is mainly specifically focusing on the GCP data engineering concepts. And Of course, some of the concepts for the development as well as admin concepts also covered here. That's a bonus. And once you complete this course, you are eligible for these two certification. You can easily crack this A certification, and after that you can go for PDE. AS is nothing but a associate cloud engineer, and after that professional data engineer. And this is where we are going to enter into the Google Cloud platform. I'm going to tell you how to interact with the Google Cloud services. Okay, before that, if you guys have any questions, I think I'm going to stop here for the day, sir. So we're going to be understanding tomorrow how we are going to interact with the Google Cloud platform like console, shell, API libraries, and web applications. So this is what is our tomorrow's concept, and we are going to see tomorrow. Yeah. Yes, of course. How CI/CD? There are plenty of services in the CI/CD for the Google Cloud platform as well. Cloud source repositories, cloud build container registries. So CI/CD is there for GCP as well, and you can achieve. I mean, if you wanted to implement in the GCP also, you can easily implement it. CI/CD, that is there. You have a service, separate services for that. Yes. Um, yes, Ashish.
So, sir, did we get notes as well for the course, or
Yes.
and as I'm in a SaaS person, I asked. So, the can you go to that diagram again?
Mm-hmm.
No, no, no. That previous one, that on premises and the machine services. Yeah, yeah, yeah. No, no, back, quite back. Yeah, yeah. So, so yeah, yeah, that one. So here the manage virtual machines means the middle tier, right? And the application services is the front end, we
Correct.
can say. Yeah. So as I am a Oracle Apps DBA, since that way I want to say, yeah,
Yeah,
right.
yeah, that works. Yes, exactly. The
So we can,
yeah,
mhm. So we can say manage physical infrastructure is as a back end. Then the manage virtual machines are nothing but the middle tier, and the manage application services nothing but our front end,
content,
right?
web
Yeah.
servers. Yes,
Okay.
correct. Okay, and anyone have any other questions? Yeah, talking about the notes, we have a specially designed notes. I'm going to provide you the access who have registered for the course, guys. You can go through the topic wise content is mentioned here. Cloud storage, cloud SQL, all of those information is here. And GCP concepts, we are going to start this one. Once all have completed their registrations, I'm going to share it with you guys. We have GCP concepts, what is Google Cloud Platform, and how to interact with the GCP interfaces, locations, and admin concepts, and how to create a free tier account, all of those things. So here Linux basics are also there. I'm going to cover all of these things, don't worry about it. Installing the SDK, GCP account creation, and Google Cloud. For each service we have a node separately created, and each nodes will have their own pages. You can look for it. Okay, so this is how cloud SQL also connecting to the SQL, data migration, all of those things. Okay, you don't need to worry about the notes. I have designed the notes very clearly, and all the content is here. You can review it. I'm gonna be following the notes also for everyday discussions. We are also following the notes, and I'm gonna give you the examples, assignments. You can also see here assignments, answers. So all of these things are clearly mentioned. I'm gonna provide you the access maybe from tomorrow onwards. So GCP notebook, if I can just give you this, link, right, you will be able to access it easily. That's it. You have a design notes for all the services, guys. Don't worry about it. Okay, yeah. Okay, guys, any other questions, anyone?
Sir, what is the fee structure for this course?
Wait a minute, guys. So there are multiple sessions are going on. Okay, so if you wanted to talk, please raise your hand. Okay, yes, Ranganath, you are asking something. No, some other guy was also asking. Yes, Lakshman, yes. Yes, it's because there's a one more session. Yeah.
Hello. So what is the fee structure?
The fee structure, guys. So for the fee, you can actually connect with the team, and they will help you on the fee. And I think it is reasonable, like as I know. But even I am not sure whether how much they are providing. You can connect with the team. They will help you. I think you can connect with the team. Yes, DURGASOFT. Right? You can connect with them. You can connect with your own IT team. They will help you on this thing. And for the fee, you can connect with him. If you need any other details related to the course, you can actually ask me here. Yes. Yes, yes, yes. Yes, correct, correct. Yeah, yeah, yeah. Yes. Any other questions, guys? Anyone?
It's a
Yes.
later part actually, but
Okay.
the
Mm-hmm.
container and the Kubernetes engine, Docker container and the Kubernetes engine. So what is the difference and between both and
Sorry, guys, this is data engineering. So we are not covering the Kubernetes. We are not covering the app engines. But
Mhm.
some amount of knowledge I am going to give you. Yes, I am going to cover this. This is a very basic question. I am going to cover you. But don't think that we are going to deploy some applications using the Kubernetes and app engines. No, that's not going to happen because this is more towards to the data engineer. Yes, I'm going to give you what is Kubernetes, what is Docker, what is Kubernetes engine, what is container registry, what is container engine. Yes, I'm going to give you. And for your question, one of the example for the container engine is a Docker.
Okay,
Container engine, containerization is a concept. It's a illustration for for achieving that containerization. We have a engines. That engine we are calling as a container engine. One of the best example for the container engine is a Docker.
okay.
Yeah.
Uh, as you said that we are going to cover the three projects actually. So, what is the idea behind each project?
So for each is a end-to-end CI/CD.
Uh-huh.
And for example, if I am talking about a data prop, I'm going to create some job one, job two pipelines. If I'm creating a orchestration in the Cloud Composer, that is DAG one, DAG two, level one DAG, level two DAG, level three DAG in the data flow one project. And so this is how it is. So each data processing system, it is nothing but a pipeline we are going to create. That pipeline, it is an end-to-end pipeline moving the data from one platform to the another.
And in second and third project?
It's the same thing. That's what I just mentioned. All of the things in three different ways: data prop, data flow, and cloud composer.
Okay.
Yeah. Yes. Any other questions, guys?
So will there be any placement assistance?
Guys, you can connect to, yes, of course. If you wanted and if you need to have any of the assistants, you can connect with the team. They will connect with me. Okay. Yeah, I can do that. But yes, I'm going to provide you the resumes for your resume building and all of those things, interview questions, commonly asked interview questions, all of those things I will share it with you. And certification dumps, certification questions, answers, I will think all of those things also I will share it with you. Yes.
So, sir, the project motto is to build a new system or deploy a new system or a deploy a system.
No, no, no. We are not deploying it. Our main is a data processing system, build a system.
Oh,
Yeah. Any other questions? Chalo. We will meet tomorrow, guys. Right? So I think this is it for the today's session. And if you guys have any questions, we will be taking up in the next session. And try attending the demo sessions, and you're going to be getting a lot of knowledge here. And after that, you can think of registrations. Yes. Okay. Yeah. Registrations are also started. Some people are already having registered for the course. You can connect with the team, and they will help you on the fee details. Okay. Yeah. Thank you all. Have a great day.